Hello and welcome. My name is Sunshine, the Project Manager, Sunshine Educational Resources, also known as Sunshine Academy. Welcome to our free online lessons in mathematics, chemistry, physics, biology, geography, economics, and many other subjects. Today in mathematics, we are going to continue with simultaneous equation. In the previous lessons, we solved problems involving simultaneous equation, but we use elimination method to solve those problems. And so today we're going to use substitution method to solve simultaneous equations. So let's proceed with this equation here, example 1. So let's see 2x plus y is equal to 16, and x plus 4y is equal to 1. Alright, so let's label this one as equation 1, and we'll label this one as equation 2. Alright, so we're going to use substitution method to solve these problems, that is to find x and y. So what we're going to do now is that from these equations, for example equation 2, let's make y, no, from equation 1, let's say from equation 1, let's make y the subject of the equation. Let's say from equation 1 we have 2x plus y is equal to 16. Now let's make y the subject of this equation, and that is possible when we say y is equal to 16. Take this 2x from the left hand side to the right hand side, it becomes minus 2x. So now we have established that y is equal to 16 minus 2x. So what we're going to do now is that in equation 2 we are going to replace y with 16 minus 2x. So let's write down equation 2. Equation 2 here says that x plus 4y is equal to 1. So instead of writing y here, we're going to replace it with 16 minus 2x. So x plus 4 bracket 16 minus 2x is equal to 1. Alright, so we have x plus 4 into 16 minus 2x is equal to 1. So x 4 times 16 is equal to plus 64. Is equal to plus 64. 4 times minus 2x is equal to minus 8x. Then is equal to 1. That's all. Alright, so we have x plus 64 minus 8x is equal to 1. So bring the like terms together. The like terms here are x minus 8x, okay, is equal to 1 minus 64. So x minus 8x is equal to minus 7x. Is equal to minus 7x is equal to 1 minus 64 is equal to minus 63. So x, divide both sides by 7. Let's say divide those sides by 7, divide by 7. Okay, 7 will cancel 7, then minus sign will cancel minus sign. So x is equal to 63 divided by 7, which is equal to 9, which is equal to 9. Alright, from this calculation it shows that x is equal to 9. X therefore is equal to 9. So x therefore is equal to 9. So what we're going to do now is that in equation 1, that is equation 1, that is 2x plus y is equal to 16. This is equation 1. So instead of writing x here now, we're going to put 9 in place of x. In place of x, we're going to write 9. So in place of writing x, we're going to write 9 because x is confirmed to be 9. So here now we're going to write 2. So it's going to be 2 times 9 plus y is equal to 16. 2 times 9 is equal to 18. plus y is equal to 16. So let's say y now is equal to 16. Remove this 18 from the left hand side to the right hand side, it becomes minus 18. Y therefore is equal to minus 2. So our x is equal to 9 and y is equal to minus 2. So we have just used substitution method to solve for x and y in this simultaneous equation. Example 2 now. Example 2. Well, example 2 is a little bit trickish. Let's see, it's 8 raised to the power x is equal to 1 divided by 2 raised to the power y. And the second equation says that 3 raised to the power x is equal to 243 divided by 9 raised to the power y. This is equation 1 and this is equation 2. Obviously, for what we have here, this is a derivative of indices, and if you've done indices, you will not have problem sorting this out. So we have to solve this using indices first before we go into simultaneous equation. We have to solve this problem using indices first before we move to using substitution method to solve for x and y. So the first thing we do, let's look at the first equation, equation 1. 8 raised to the power x can be written as 2 raised to the power 3x equal to, this one here can be written as 2 raised to the power 0 divided by 2 raised to the power y. Okay, and this second equation, this is now motivated equation 1, and this 3x can be also be written as 3x. We can still write it as 3x. 3x is equal to 243 is the same thing as writing 3 raised to the power 5. 3 raised to the power 5 divided by 9 raised to the power y is the same as writing 3 raised to the power 2y. Okay, so this is equation 2 now. This is our mutilated equation 2. All right, the first equation can also be written as, equation 1 can be written as 3x is equal to 0 minus y. And the second equation can also be written as x is equal to 5 minus 2y. So this is our final equation 1 and this is our final equation 2. This is what we're going to use substitution method now to find x and y. So let's find x and y now. All right, from equation 2, x is equal to 5 minus 2y. From equation 2, we have that x is equal to 5 minus 2y. So we're going to replace this in equation 1. So you have 3 times, instead of writing x, I'm going to write 5 minus 2y is equal to minus y. Okay, so multiply 3 times 5, you have 15. 3 times minus 2y is equal to minus 6y. Okay, is equal to minus y. So 15 minus 6y is equal to minus y. Now take this y to the other side. 15 is equal to minus y plus 6y. So 15 is equal to minus y plus 6y is equal to 5y. So divide this side by 5, divide this side by 5. 5 we cancel 5. 5 here, 1, 5 here, 3. So therefore y is equal to 3. So y is equal to 3. Now let's substitute for y in equation 2 to find x. So in equation 2, x is equal to 5 minus 2 times 3, since y is equal to 3. So instead of writing y, we're going to write 3. So x is equal to 5 minus 2 times 3, 6. Therefore, x is equal to minus 1. Example 3 says that 2a minus 3b is equal to 5, and a minus b is equal to 4. So this is equation 1 and this is equation 2. Alright, from equation 2, let's use equation 2 now. From equation 2, you will agree with me that a is equal to 4 plus b. From equation 2, a is equal to 4 plus b. Let's substitute for a in equation 1. So you have 2a minus 3b is equal to 5. So you now have 2 times 4 plus b, bracket open and close, minus 3b is equal to 5. Alright, let's multiply this out now. 2 times 4, you have 8. 2 times plus 4b, you have plus 2b, minus 3b is equal to 5. So 2b minus 3b, 8 minus b is equal to 5. 2b minus 2b is minus b. So 8 minus b is equal to 5. So minus b now is equal to 5 minus 8. Therefore, minus b is equal to minus 3. Minus, we cancel minus, so b is equal to 3. Now let's substitute for b in equation 1. This is equation 1. Equation 1 is 2a minus 3b is equal to 5. 2a minus 3b is equal to 5. So you have 2a minus 3b is equal to 5. And here we're told that b is equal to 3. So all we're going to do now is to multiply 2 by a minus 3 times, instead of writing b, we're going to write 3, which is equal to 5. So 2a minus, this is a, 3 times 3 is 9, is equal to 5. So 2a is going to be equal to 5 minus 5 plus 9. Take this minus 9 from the left hand side to the right hand side, so it becomes 5 plus 9. So 2a is equal to 5 plus 9 is 14. So divide both sides by 2, divide both sides by 2. So you have 2 here 1, 2 here 1, so 2 here 1 and 2 here 7. So therefore a is equal to 7. So let's move to example number 4 now. So example 4 says that 3x plus y is equal to 1, and 2x minus y is equal to 4. So this is equation 1 and this is equation 2. So we are using substitution method to solve for this simultaneous equation. So from equation 1, y therefore is equal to 1 minus 3x. From equation 1, you can see that y is automatically equal to 1 minus 3x. Okay, now we're going to substitute for y in equation 2. In equation 2, we're going to substitute for y. So it's going to be 2x. Instead of writing y, we're going to write minus 1 minus 3x is equal to 4. It's equal to 4. So 2x minus 1, minus times 1, you get minus 1, minus times this, you get plus 3x is equal to 4. So bring the like terms together. 2x plus 3x is equal to 4 plus 1. 2x plus 3x is equal to 5x, is equal to 4 plus 1 is 5. So divide both sides by 5 by 5. This, we cancel this. So x is equal to 5 over 5 is equal to 1. So x is equal to 1. So x is equal to 1, and so let's substitute for x. So from equation 1, 3x plus y is equal to 1. X is equal to 1. So that is 3 times 1 plus y is equal to 1. So 3 plus y is equal to 1. Therefore, y is equal to 1 minus 3. Y therefore is equal to minus 2. Let's move to example number 5. So example number 5 says that 3x minus 7y is equal to 1, and x minus 4y is equal to minus 3. So this is equation 1 and this is equation 2. So what we'll do now is that from equation 2, x is equal to minus 3. X is equal to minus 3 plus 4y. From equation 2, x is equal to minus 3 plus 4y. So we're going to substitute for x in equation 1. So instead of writing 3 times minus 3 plus 4y minus 7y is equal to 1. This, using equation 1 now, we substitute for x in equation 1. So 3 times minus 3, you get minus 9. 3 times plus 4, you get plus 12y minus 7y is equal to 1. So let's bring the like terms together. 12y minus 7y is equal to 5y equal to 1. I'm going to take this minus sign on the left hand side to the right hand side. It becomes plus 9. So 5y is equal to 10. Divide both sides by 5, and then you have 5, we cancel 5. So y is equal to 5 here, 1, 5 here, you have 2. Y is equal to 2. Now we're going to substitute for y in equation 2. So we're going to substitute for y now in equation 2. So x minus 4 times, instead of writing y, we're going to write 2, is equal to minus 3. So x minus 8 is equal to minus 3. So x is equal to minus 3 plus 8. X therefore is equal to 5. So that is it for today. Today we've been able to go through simultaneous equation, how to solve for simultaneous equation using substitution method. In the previous lessons we learned how to solve simultaneous equation using elimination method. Take your time to practice this and then you will get to understand it more and more. Thank you very much for watching, and God bless you. If you like this video, give us a thumbs up and subscribe to our YouTube channel. Thank you very much for watching.